Diamond, and today I'm going to be showing y'all how to solve a physics motion problem with displacement, velocity, and acceleration. Our first step is going to be to find our change in time, which is going to be represented by delta t. And we find delta t by taking our final time minus our initial time. Our final time is 3:37 p.m. and our initial time is 3 o'clock p.m. So we're going to subtract these two. Which gives me a difference of 37 minutes. However, we're traveling in hours, so we have to convert our minutes into hours. And we do that 60 minutes in 1 hour, so we're going to divide our 37 minutes by 60 minutes. I'm going to divide these two. I get my delta t is going to be equal to 0.617 hours. Our next step is going to be to find our displacement. Displacement is the net change in position and is represented by delta x. So we find our displacement by taking our final position minus our initial position, which in this case, our final position is 185 and our initial position is 126. We put these into the calculator, and I get a difference of 59. So 59, but they're also traveling in miles, and don't forget, they're also traveling north. So we're traveling 59 miles north. And that's going to be our displacement. Our next step is going to be to find our average velocity. Velocity is another word for speed, or how fast or slow something is traveling. And velocity is going to be represented by our v average. And we find our average velocity by taking our delta x, which is displacement, divided by our time interval. So we can go to our givens over here and see that our delta x is the 50. So we can go over here and see that our delta x is our 59 miles north. And we're going to divide it by our time interval, which is a 0.617 hours. So I'm going to put these ones into my calculator. And I get 95.6. We can't get our units, so it's going to be miles per hour north. And that's our average velocity. Last but not least, it's time to find our average acceleration. Acceleration is another word for change, so we want to know what our average rate of change is that the rover was traveling. And we find it. We find average acceleration using this formula. It is A average, and we're going to take our final velocity minus our initial velocity, and we're going to divide the whole thing by our time interval, delta t. Now that we have this formula, we just plug in our values. We're going to take our final velocity, which is 105 miles per hour, minus our initial velocity of 112 miles per hour. And we're going to divide that whole thing by delta t, which is the 0.617 hours. Let's plug it into the calculator and see what we get. For our average acceleration, I got negative 11.35 miles per second. Acceleration is negative, which means the rover slowed down while still traveling north. In the end, we were able to find our rover's displacement, which is 59 miles north, his average velocity, which is 95.6 miles per hour north, and his average acceleration, which is negative 11.35 miles per hour. And our acceleration is negative, which means the rover slowed down while still traveling north.